So picking up on some of the themes that Alex mentioned and David actually mentioned as well, we're going to focus today on construction data. It's sort of the big thing that we think is being undervalued in the construction industry and something that we can do something about it. Technology holds the key to unlocking the value of that construction data. By way of introduction, Envision, we've been developing Envision, Hugh and I, the co-founders of the company, for almost 10 years now. And that's been continuous refinement of the software and building it over time. And thanks to all the companies here who are current clients of ours have helped us on that journey. But our aim is to try to bring visibility from the field to the construction project execution team so that we can provide insights into what's happening. We've been involved in Australia alone in about 270 projects now across all sorts of different industries, and we're now starting to see demand for our technology in Papua New Guinea, led through Clough, and into Mongolia we've got a project, and now also in North America. In those projects that we've done, we've been exposed to sectors including S&Ps, civil infrastructure, mining, oil and gas, road, rail, all those sorts of types of things. And not only just from the construction delivery side of things, we're also starting to get involved in the design, deliverable, and also commissioning. A couple of those key example projects are like Brisbane Second Runway, Port Moresby Power Station with Clough, as I mentioned, and the M4, M5 link tunnels with Lendlease Boyd's JV, which is actually using it a lot for design, track and design projects. So that experience that we've built up through delivering lots of those projects, we've seen firsthand these core industry challenges that Alex mentioned in his presentation around poor productivity. We see that all the time. We sort of see the challenges of cost and schedule overruns all the time. And we also see a lot of these issues around dispute resolution and stuff like that, and understanding the costs and tracking that of disputes. But more than anything, we see digital adoption being a challenge and the industry being reluctant to change. My background is as mechanical aerospace engineer, and that's quite a technologically, I guess, by necessity, advanced industry. And when I came to construction, because my background is not that, I was sort of surprised and it felt strange, you know, like I think when I worked on F-35 program, we had one challenge, and I'll give you a little anecdote here. We had one challenge, okay, so we're designing an aircraft, we need the Turkish military to be able to change the engine in the aircraft without getting the aircraft for another 5 years. How do they do that? Well, the team I was working with at Lockheed Martin had a complete virtual environment with haptic feedback and gloves, and this is in 2004, where they could train remotely the Turkish military to be able to change the engine part. So their adoption of technology and in the way they deliver those sorts of things was quite different to what it is when I came to construction. So those industry challenges that we see there, we often see them presented in white papers and in discussion things in McKinsey and stuff like that, and they can seem abstract and academic, but they actually have real impacts on companies. So here's some news clippings from companies that have actually suffered from being able to try and sustainably deliver projects and have, you know, fallen to overcome by those problems. And you know, it might seem like a news clipping, but they're companies that employ people like you and I who now have got to find different jobs and that. So the key thing that we want to, I guess, communicate is that we want to give the project leadership team information as quickly as possible about what's happening on their project, so they feel like you get good news is bad news fast, and knowing quickly about a problem is really a valuable thing. So if you're running a construction project and you're spending more than $1 million a day on labour and plant and stuff, you want to know if you don't want to wait till the end of the month to know where you are. You want to know as soon as practically possible, ideally next day, what happened on site, how much did I achieve, how much did I spend, and get that feedback. So like the case of the Titanic, if you're heading along, if you could have known about that iceberg a little bit earlier, you would have had time to turn the ship. So we're focusing on how do we do something about that, and we think the key is making construction data more valuable and bringing that to the fore of mind so that we can acquire it, analyse it, and provide insight into what's happening with that data. Data has been sort of hyped in the media, you know, and you see reports that data is more valuable than oil and things like that. And this analogy between data and oil actually comes about from a British mathematician, Clive Humley, who in 2006, I think it was, founded the Tesco Club Card loyalty program, where he valued all the data of customers for Tesco. And the analogy really is sort of lost a little bit, but what he was trying to say was that data, like oil, needs to be refined before you can unlock the value of it. So we take raw crude oil out of the ground, we refine it, we get other sorts of oils and fuels, and that's where the value is. And the same thing is with data. We need to take it, refine it, before we can unlock the value that it gives us. So just as a little example of how work practices have changed, or life's changed, does anyone remember what this is? So do you remember having an open on your lap, hoping that traffic lights don't change so you can work out, hang on, I've got to go to page 400 and you know. So things have changed obviously since those exciting times. I used Google this morning and put in our office, it worked out where I was. I worked out, it found me the location automatically. It gave me 3 different paths, travel time, and all that sort of stuff. It showed me where roadworks were, it showed me the flow speed of the traffic on the network, and all that information that I could send to my mobile phone. So when we drove here, we could track our path and see that in real time. And that's fantastic information. Does anyone know how Google works out the speed on the road network? No. Yeah? So what they're doing actually, if you've got location services switched on your phone, is it's acquiring that information and updating the map real time with that information of the people travelling through the road network. So Google doesn't give you, well, what it estimates at the start of your journey, what it is halfway through, and then what at the end. It actually gives you continuous feedback as you're driving. And I think that analogy is what we're trying to bring to construction. We want to give you that feedback as you're progressing through the journey, so that you might just say, oh, there's congestion here, I'll take a different path. So it's the same way. So interestingly, if you're interested, you can still buy the tools at Officeworks. So let's talk more specifically about actual construction data now. And I'm not talking about the design documentation, I'm not talking about document management, I'm not talking about markup of drawings and those things. They're absolutely important and they communicate our design intent, what we're trying to build, and so forth. What I'm talking about is the data that we use and create and capture and have to analyse to be able to work out where we are from a cost and progress position every day, even hourly on projects. So information like subcontractor dockets, load counts, who's attending on site, weighage records, survey data, GPS locations of equipment breakdowns, utilisation, all that sort of raw information that we use and have to absorb into our project leadership team to be able to make decisions. So that's what I'm calling the raw data, the crude oil, if you like. So the construction information informs our decisions, and we get that by refining the raw data. So when we take all that information I showed on the previous slide and we turn it into things like earned value and percent completes and CPI and SPI and daily production and cost rates and those sorts of things, that informs our decisions about what we do as a leadership team, as management and engineers, to make decisions about how do we steer the project in the right direction. But the challenge is not easy. Of course, our data's in all sorts of weird and wonderful formats. It doesn't come all in a structured way that we can just tap into it and pull it down and make those assessments. We get paper, we get API messages, we get things from weather surveys, we get CSV files from turnstile gates, we get handwritten scrawl from weigh bridges and all sorts of data like that we need to bring together. And the problem is that having that tax of having to bring the data together into a format that we can understand is actually something we've got to pay continuously all the time, and it consumes a significant amount of unproductive administrative effort. So I think there's sort of like a maturity, if you like, of the way we capture data from paper through to scanned handwriting, free text, structured data, up towards self-describing data. And what I mean by self-describing data is that the schema and the data itself is in the one payload, so it describes what's the contents of it. So one of the things that we observe in all the projects that we talk to is that senior project engineers, which are a highly valued resource, or planning and improvement are actually spending a significant amount of time. We estimate it's around 70% of their effort at end of month is actually determining their cost and progress position. And that means they're only leaving 30% of their time for forecasting and improvement. And that's not ideal, and that's not how we make projects better. We need to utilise their thought power for value-adding activity, not manipulating and crunching numbers. So let's look at one of the culprits here of this thing. The humble site docket. You often see them in a triplicate book, and you often see them torn on the backs of utes and scrumpled up in people's back pockets and things like that. And interestingly, the site docket actually carries an enormous amount of information, so it's a great example of this problem. So it contains things like what materials came on site, who started when, what equipment they used, you know, how do we allocate that work to different cost codes, who did the approval and that sort of thing. So while it seems a simple piece of paper, and you'd think to replace it would be simple, but it's not, because it embeds a lot of data and it enables a lot of downstream processes. But so when it's paper, it actually is a barrier to those downstream processes flowing. So if we can make it electronic, we can improve those processes. So typically, we see on projects between a 5 to 10 day delay between the work getting done and those actuals being captured and analysed. And that 5 to 10 day delay may not seem significant in isolation, but when that's happening for every piece of information that's coming in, it's like effectively driving your car only being able to look in reverse about what's happening, because you've got a lag between what happened yesterday. You don't know until 5 to 10 days later, which I don't think as many project managers would want that. So, to elaborate the point a little bit more, imagine we have this chart here, we call this the action distance, and it's the time really between something happening on the project, whether you're blocked access on site, or something milestone has been completed, or some problem occurs, to the time where you can take action. And there's three sorts of delays that happen here. There's the data delay, the latency of capturing that data. There's the latency of analysing that data, bringing it all together and say, is there really a problem? And then there's taking action with the decision that you've got. And those two together, we want to try and compress that as much as possible. So let's look at a case study where we tried to do this. So this is a project that we did a couple of years ago with CPB and Origin. Large project, so it's $250 million recurring sustaining gas infrastructure. And that project was generating around 400 dockets per day, or around 130,000 dockets annually. And that's from individual contractors writing up their dockets and handing them in and so forth. And the typical turnaround for getting the data was roughly between 7 to 10 days the project teams had their data. So we moved them to an electronic process where the individual subcontractors on mobile devices captured their own dockets, and we had an electronic approval and review process. And that saved that project around 110,000 dockets annually. And it had two big effects. So the first one, obviously, is that we reduced the amount of administrative effort. So the admin team, which was around 10 strong, would be able to reduce to be 2 people. So there was an immediate FTE headcount reduction of 8 FTEs, which is very significant. Secondly, the impact that... Is that like, it's like the end of the Porky Pig solution? That's all. It's like, so, I won't go any further. You know who you are. So the second big impact that this has is it gave reliable data very quickly to the team. And he's the controls manager and the project director actually articulating how it impacted on their world. We actually, to try and understand this a bit better, did a sort of value stream mapping exercise where we tried to analyse the old process and the new process and understand where the waste was in that. And we came up with between 30 and 60 extra engineering minutes were available for engineers to do stuff with their time. And that might be more planning, it might be improving safety, walking around the site. It also might be going home on time as well. But anecdotally from the project, they say it's more like 20% of engineering time is available, and that's significant, definitely. So what we think that a strategy for improving the way projects are running is incrementally, decision by decision, small decisions, better quality decisions. So work happens on site, we collect some site data, we use that information to determine physical progress and cost, and then we take action to do something. So let me give you an example about what can happen inadvertently when we don't use an electronic system. So imagine we've got our site docket here, and that's fine, you see one or two of them. But imagine you've got 230 contractors on site, and they're generating one per day and handing them in a haphazard approach. The engineers pick them up together with the load sheets that are attached to them, and they digest them and enter them into progress tracking sheets, and they usually split that up per discipline. So they'll take a docket and they'll probably have to split it into a couple of different ways to get different disciplines. And they might have a number of different areas they're operating. One project that we spoke to, one engineer was very proud that he had 80 different areas he had broken his things down into. So that's great. And then they use that information to generate their reports and their forecasts. So when the project manager asks the engineering team, where are we? Oh, just let me wrangle up the spreadsheets and I'll tell you the answer, is usually what happens there. But it's not all. The dockets actually go to the admin team and they have to digest them into registers, which are typically one spreadsheet per subcontractor company. Most of them are in excess of 200 on a decent sized construction project, 200 different registers. And so when the invoices come in then, they need to be reconciled against those to make sure we're not unfairly paying. And then those accruals then end up in the finance system at the end of the month. So that's where you've got a true record. So you might think, well, why are you doing this? Why aren't we leveraging the corporate systems to make this more effective? Well, the corporate systems, like an SAP or a JD Edwards, is not intended for this level of data capture and processing at this high fidelity. So what happens is the project teams have their own site execution and data management, which is generally in spreadsheets. So when you're making decisions in the absence of data, you're susceptible to cognitive biases. And we all suffer from those things. Experience is a great differentiator, but if you don't have experience in that area when you're learning, cognitive biases definitely are a factor. And one of the key ones in projects is this, what's called the planning fallacy, which is our tendency to underestimate how long projects take and overestimate how quickly we can get things done. So the casebook study for that is the Sydney Opera House, which I think the original budget was $7 million in 4 years and ended up being 14 years and $104 million. So that's probably on the long tail of that chart that we saw earlier today. So when you don't have the data, you're just another person with an opinion. This guy, I'm not sure if you're aware who he is, Edward Deming, is an American mechanical engineer, data scientist who helped Japanese manufacturing industry come out of the Second World War by bringing statistical process control, which is measuring how manufacturing is progressing, and the plan, do, check, act cycle. And that became the genesis of the Toyota manufacturing process and the genesis of Lean. He also said that in God we trust, but everyone else must bring data. So what I want to say, I guess, is start to work up to the point is that we're at the situation now where we've actually passed peak mobile device adoption in Australia. Maybe not worldwide, but in Australia, we're not buying at a faster rate any more mobile phones now. So there's a great market penetration in mobile devices. We've also seen the rise in capability of cloud computing infrastructure, and people are accepting to have their data in the cloud, be processed and that sort of thing. So those two things are like a perfect storm for enabling us to better use the data that we have on our construction sites. I think the other factor is that when we start to make data-driven decisions, we have the effect of making what we measure. If we're measuring something on a daily basis, we have the effect of trying to make that better. That's why in manufacturing facilities you always see 200 days since the last lost time injury. They're wanting to make things safe, so they make those things big and visible. It's a lean principle. So if we continue as an industry to do the current practice of getting highly paid and educated engineers to build a lot of spreadsheets that are highly complex based on data that's out of date and maybe not as accurate as it could be, we're not going to be able to give them the information to make better decisions, and we're not going to be able to free them up with time to be able to implement those decisions. So let me leave you with three things that that I'd like to hope you take away is that I think we can make projects better and have better outcomes by making better decisions. And it's not the big grandiose decisions, it's better day-to-day decisions with the resources that we've got at hand. And those better decisions require better information, and that's more accurate and sooner. Because as we've seen from that chart, the value of the information decays over time if we don't utilise it. And construction data is not being viewed as an asset at the moment. It's an asset. Construction companies have projects themselves have a huge amount of data that they're generating, but they're not treating it as an asset that they can use. And I think we're in a unique situation at the moment where technology is providing the opportunity to unlock the value and refine our data, like in the analogy of refining oil, to get more value out of what we're collecting.